In this video series, I work through a math problem or problems each video. One way to solve equations with rational expressions is first finding the least common denominator of all the fractions in the equation, then multiplying the entire equation by that denominator before solving the simplified equation. Let's take a look at the example. Solve the following equation. We have 4 over x minus 4 plus 1 over x minus 5 is equal to 11 over x minus 1. If we take a look at the three fractions in the equation, they all have linear factors as in the denominators. So if we compare them, we see that they're all different. So the least common denominator for these three fractions is x minus 4 multiplied by x minus 5 multiplied by x minus 1. So essentially the multiple of all the three denominators multiplied together. So the next step would be to multiply the entire equation through by that common denominator. When we do, let's start by looking at what it does to the first fraction. The x minus 4s will cancel out, and we are left with the numerator multiplied by the multiple of the other two denominators. So we get 4 multiplied by x minus 5 multiplied by x minus 1. And if we look at the next fraction, the x minus 5s will cancel out, and we're left with 1 multiplied by x minus 4 multiplied by x minus 1. Since multiplying anything by 1 will give us a result of that other number besides 1, I'll just skip right into 1 and write everything else, which is x minus 1, and x minus 4. On the other side of the equation, we have 11, and the x minus 1s will cancel out. So we end up with x minus 4 and x minus 5. Next, I'll go ahead and use FOIL on these three expressions to multiply out the multiple of the two linear factors. I'll copy the 4 in this step, and if we multiply out x minus 5 multiplied by x minus 1, we get x squared minus 5x and minus x is 6x, and minus 5 multiplied by minus 1 is plus 5, plus x times x is x squared, minus 4 and minus 1 gives us minus 5x, minus 4 times minus 1 is plus 4, is equal to, once again we'll keep the 11 for this step, x times x is x squared, minus 4x minus 5x is minus 9x, and minus 4 times minus 5 is plus 20. Now in this step, I'll go ahead and distribute the 4 and 11. When we distribute 4, we get 4x squared minus 24x plus 20 plus x squared minus 5x plus 4 is equal to, and when we distribute 11 to the expression in this parenthesis, we get 11x squared minus 99x, and 11 times 20 is 11 times 2, which is 22, times 10, which is 220. Next, I'll go ahead and combine everything on the left hand side. So I'll combine the like terms, so 4x squared plus x squared is equal to 5x squared, minus 24x minus 5x is minus 29x, and 20 plus 4 is equal to 24. And that's equal to the expression we had just written on the right hand side. So that's 11x squared minus 99x plus 220. Now we need to combine the left and right hand sides. We can move and combine them in either way, but since 11 is bigger than 5, I'll go ahead and move everything to the right hand side of the equation. So we'll be subtracting 5x squared, adding 29x, and subtracting 24. I'm going to do the same thing to the other side, but since I specifically chose these numbers to cancel everything out, on the left hand side we would end up with 0. 11x squared minus 5x squared is 6x squared, minus 99 plus 29 gives us minus 70x, and 220 minus 20 gives us 200, and when we subtract 4 from that, we end up with plus 196. And if I look at the coefficients on the right hand side, 6 minus 70 and y96, they all have a factor of 2 in common. So I can go ahead and multiply or divide this equation through by 2, and that gives us 0 is equal to 3x squared minus 35x, and if we divide 196 by 2, we get 2 times 9 is 18, 16 divided by 2 is 8, so we need to solve the equation 3x squared minus 35x plus 98 is equal to 0 for x. Since we need to factor this equation, let's see what 98 factors into. 98 can be divisible by 2, and if we divide this by 2, we get 2 multiplied by 49, and 49 is equal to 7 times 7, so 98 is equal to 2 times 7 squared. So we have 3x squared minus 35x plus 98, which can be factored into 2 plus 7 squared, and we're going to factor this expression next. 3, the coefficient of x squared is a prime number, so when we factor this part, we end up with 3x and x. Next, if we take a look at 35, 35 is a multiple of 7. Now, we have 7 squared as a factor of 98, so we could try to get one of the numbers to get both of the factors of 7. If we do, one of the terms in the middle will be multiple of 49, and the other number won't be a multiple of 7, and we won't end up with 35. So we have to make sure that both of these numbers here end up with a multiple of 7. And the remaining number 2 will have to end up with one of these numbers. And that's only 2 possibilities. So we can go ahead and test out both cases. So if we let this factor get the factor of 2, we can write 14 here. And the other case we need to check is writing 14 here and writing 7 here. So if this does actually factor nicely, then one of these two factorizations should work. And let's see, 98 is a positive number here. So either both of these signs are positive or both minus, subtraction sign, minus signs. And if we look at the sign for minus 35, that's a minus sign here, which means we do need both minus signs here, and the two middle terms should add together, or in this case subtract together, but they're both the same sign. So let's go ahead and see what we get for the first factorization. 3 times 14 or minus 14 will give us minus 242, and minus 7 times 1 is minus 7. So minus 42 minus 7 is minus 49, and that doesn't match minus 35. If we multiply the second expression out and just look at the middle term, 3 times minus 7 is minus 21, and minus 14 times 1 is minus 14. So if we combine these two numbers together, we get minus 35. and that does match the coefficient of the linear term. So the second factorization is the one that we want. And to solve for x, we'll set each of the linear factors equal to 0. To solve the first equation for x, we first add 14 to both sides of the equation, and that gives us 3x is equal to 14. And we can add 7 to both sides of the second equation, and we already solved the second equation for x. To solve the first equation for x, we divide both sides of the equation by 3, and that gives us x is equal to 14 over 3, or x is equal to 7. Normally, we go ahead and test out these numbers to make sure that they actually work out, because sometimes we end up with extraneous solutions that won't actually work in the original equation. But in this case, if we do actually try out the numbers, we will find out that they work. I won't actually test them out here, but both of these numbers will actually work in the equation. So the two solutions to this equation are 14 over 3 and 7.